So this is our problem, arc cosine ln x divided by x dx. So from here we can make a u sub, and we're going to use ln x since the derivative of that is 1 over x dx. Plug that back in, we get arc cosine u du. And from here we can use integration by parts. So we're going to use our u, or in this case w, since we already use u. That's going to be arc cosine u, since the Liate acronym requires us to use the inverse trig as our option. So the integral of arc cosine u would be -1 minus u squared, square root of that. And we also need v, so that would just be dv is du, and integral of that is u. So if we use our integration by parts formula, we're going to get v times w, so that's going to be arc cosine u times u minus the integral of v, so that's u, and dw, so this whole thing. And do some simplification, move the negative signs out. So we're going to get arc cosine u times the integral of u over 1 minus u squared, square root of that. And we can also make another u sub. So in this case, we're going to use z. We're going to put 1 minus u squared. dz is -2u du. And that's convenient for us because we have u du already. So move the -2 over, we get -half dz equals u du. So we're gonna plug that back in again to our equation. So 1 over z, because it's still the square root, times -half dz. Move the -half outside, and we're gonna integrate z to the -half. So that would be 2z to the power of half plus c. So now we can just plug that back in. So we have arc cosine u times -half 2z to the power of half plus c. And simplification, cross out the 2's. Now we have arc cosine u times u, and we're going to plug in z from earlier. So that's 1 minus u squared, square root of that plus c. And then we're almost done. Now we just have to plug in u from earlier, which is our ln of x. So if we plug that back in, we get ln of x times arc cosine ln of x minus 1 minus ln of x squared, square root of that plus c.